You have often written things like this, sequences like this, when trying to solve for an angle using trigonometry. This function here, we write sine to the power of -1. It's called inverse sine. Actually, that's more of a description. What it's actually called is arcsin. The notation is normally sine to the -1. The word is arcsin. It is the inverse of sine. That's why I said that's actually the description. But there's a problem. If you ask for sine to the -1, your calculator will give you the reference angle. But we know there's actually many angles. There are many other angles that have the same sine value of 1/2. So what we want to do is define the inverse trig functions as functions. That is to say, they have to pass the vertical line test. There's only one possible output for each input. And this is actually what your calculator does. What we do is we define it over a particular area, a particular domain. So this is the normal sine curve. So if we're looking for a particular value, there will be an infinite number of solutions all the way along, every time we go across the curve. So what we do is we restrict it to only this section of the curve, from -90 to +90, or from -π/2 to +π/2. Because within this region, it's 1-to-1. Within this region, the inverse will be a function. So for sine, it's always within -90 to +90, or -π/2 to +π/2. For cos, we use this part of the cos curve, between 0 and 180, between 0 and pi. And in this section, we are going to get all the possible values for cos. So this is where inverse cos is defined. And then for tan, we go back to the same as for sine. We look at just the first, what's what I'm looking for? The central part of the tan curve. The section between -90 and +90 is one continuous curve, so this is the region, the domain, within which inverse tan is defined. Okay, actually that would make it the range of inverse tan. It's the domain of tan, or the range of inverse tan, -π/2 to π/2. So to summarise, arcsin, written sine to the -1, is the angle between -π/2 and π/2, or -90 and 90, at which the sine of that angle is equal to the original argument here. Arccos, or cos to the -1, is the angle between 0 and pi, or 0 and 180 degrees. That gives this right cos value. And arctan, or tan to the -1, is the angle between -90 and 90, -π/2 and π/2, where the tan value is what we're looking for. And a reminder, sine to the -1 doesn't mean 1 over sine. Cos to the -1 doesn't mean 1 over cos. Tan to the -1 doesn't mean 1 over tan. By this notation, we actually mean arcsine, arccos, arctan.